All right, are you ready to learn about lead? I hope so. Let's do this thing. Heavy metals are naturally found in the earth, but due to human activity like mining, these heavy metals are brought to the surface and utilized. There's some examples of heavy metals listed on the bottom of this page. Lead, just like all the other heavy metals, are found in the Earth's crust. As said before, these metals are removed through mining, and these men are hard at work in the lead mine. Lead is mined all over the world. It can be mined in its pure form, or it can be found in multiple different compounds like lead acetate, lead nitrate, lead oxide, and a ton more. Lead is an element, so it has a ton of properties. Things including the color and state of matter, which is this bluish gray metal as a solid state, down to its density, which is 11.34 grams per centimeter cubed. That's pretty dense. The melting point of lead is 327.2 degrees Celsius, which is actually pretty low, which is why it is utilized in so many different things. Now, if you put a chunk of lead in water, it wouldn't be soluble. It would stay lead. But if you add it to either nitric or sulfuric acid, it becomes soluble. It's actually soluble under any sort of conditions which get a pH below 5.4. It's a non-volatile substance, so all in all, it's pretty solid. Now, lead isn't often found in its pure state. It's often found in a compound. There are, as said before, a ton of compounds that include lead, and none of them have the same properties as the pure lead does. Majority of them have a decrease in density. The color changed, and if you look off to the side, this chart shows you approximately the color of the compound, and they become much more water soluble. So the fact that they become water soluble in the compound, that means lead is easily accessible in the soil and water systems. So there are three places lead could end up. It could end up in the soil, the water, or the atmosphere. This is the soil. Lead is very persistent in soil, which means it binds tightly to those soil particles. It does not want to move. It binds to the clay, silt, and organic matter through the electrostatic and chemical processes. It binds most tightly to the organic matter. This means that leaching of the lead into the water sources doesn't occur because that bond is so tight. Lead can enter the water, but it doesn't like to do it very much. One way that lead enters the water is through erosion of lead-containing soil, meaning if the soil originally had lead in it and it eroded into the water, then we could have the transfer of lead into that water source. It can also go into a water source if there is water runoff through the soil, but again, lead likes to bind so tightly with those soil particles that it doesn't really want to move. Once lead does get into the water, if it gets into the water, it stays undissolved, so it stays in its solid form, but very, very small particles. Lead can enter the atmosphere, but it's not going to stay there. It can be emitted into the atmosphere through emissions from factories where they are working with lead, or through burning of gasoline for transportation. It wasn't very long ago when gases were considered better if they had lead in them. These were called leaded gas. So when these particles of lead go up into the air, large particles tend to settle up very quickly and are often very close to their original source. Smaller particles can travel far distances and settle out. A majority of lead particles are found within 10 kilometers of their original source. They can fall out of the sky through wet or dry deposition, but again, the closer they are to their source is where they will be found. Bioavailability is a measurement of how much of the compound can get into the environment, and the amount of lead that gets into the biotic environment relies completely on the conditions of the environment. So lead is more bioavailable when there's a high pH because that allows the lead to become more soluble. Having a low organic matter content because lead tends to bind very tightly with organic matter, as well as having a high water content of the soils. If lead does become bioavailable, you might be asking yourself, what's going to happen to that lead? Well, it is going to bioaccumulate into organisms, meaning it will absorb or be taken in by living things in the environment. So the longer the organism is exposed to this lead, the more toxic it becomes to that organism. But it will not biomagnify. This means that lead is not passed on from one organism to another up the food chain, so the effects will not be magnified. In the past, lead was much more of an issue than it is today. That's because at one time they were using lead in paint. They were using lead to make old toys, to build lead pipes, to put lead in gasoline. But just because these things are not happening as often now does not mean that lead is not an issue in our environment. A lot of jobs, pottery, lead smelters, things like that are putting more lead into the atmosphere. Lead is very toxic to human health. The CDC reports that there is no amount of lead that's safe for the human body to ingest. If a human does ingest a high enough concentration of lead, there can be very adverse effects. These would be things like colic or constipation, abdominal pain, vomiting, low IQ, low attention spans, behavior changes to the negative. If a woman is pregnant and comes in contact with this lead, it can lead to preterm delivery, low birth rate, impaired mental development of the fetus, and these are even more compounded if the woman has a low amount of calcium in her pregnancy diet, because lead is stored in bones. And so if there is not calcium to keep the bones strong, that means the lead is much easier to leach out of the bones. When getting lead out of the environment, we focus on getting it out of the soil because that's where most of the lead ends up. One way we can do this is by digging up the soil and going through what is called a soil washing process. This is where the soil is dug up and washed with a chelating solution. This chelate solution pulls the metal particles together so they are able to be extracted out of the soil. A limitation of this is that a solution must be tailored to the site. This relies on the pH of the soil, the water content, and any other characteristics of the soil that allows for that lead to be taken out. Also, the particle size of lead determines the effectiveness. If the lead particles are really small, this is going to be very challenging. Acid leaching is another way to do this. So again, the soil is dug up and the lead compounds that are found in the soil are converted into lead carbonate. Lead carbonate is soluble in this acid, and so this acid is sprayed on the soil, the lead is pulled out, and the acid is able to be recycled for use again. It does create some waste products, and that waste is required to have additional treatment to it before it can be disposed of. Another remediation strategy is called solidification and stabilization. This happens in the ground. So the goal is to convert the lead into a compound that is the least soluble or immobile, and to do that, this SS agent is mixed within the soil. When we put this agent with the soil, everything must be mixed evenly and completely to be effective. So it doesn't actually take any of the lead out, but it makes it much safer for the environment. Another form of remediation is called vitrification. This is when very large electrodes are inserted into the soil and they shoot an electric charge through it. the soil gets crazy hot and melts the lead, which allows the lead to be collected through a negative pressure system, so it gets sucked out. Some problems with this technique is that it requires ridiculously high temperatures to melt the lead, and to have that happening in the soil is very challenging. It also takes a really long time to complete this safely because it takes a long time to heat it up as well as cool down the soil and the area. A bioremediation way of removing lead from the soil is a multi-step process. And the first step is to lower the soil's pH. To do this, you need to add some sort of acidic compost or acidic soil amendments to the soil. This would include adding things like sulfur or coffee grounds or pine needles directly to the soil and mixing it in. This will allow the lead to become more mobile because more acidic soil allows for more mobile lead. The next thing is by adding hyperaccumulating plants. These are plants that absorb or accumulate heavy metals, in this case lead. Some of these plants would be things like geraniums, corn, sunflower, brown mustard. There are a ton of other plants. The more phytoextractors that get used at one time, the better, but some limitations are the soil conditions must remain optimal for this use. Acidic environments might be toxic to things that already live there, and after the fact, lead accumulating plants like these corns or sunflowers must be disposed of properly. You cannot just compost it or put it back into the environment, or the lead goes right back in. Another issue is that you need a heck of a lot of coffee grounds to lower the pH of a large amount of soil. So now that you know a little bit about lead, what it can do, what it comes from, how it impacts human health, and some ways to get it out of the soil, are you ready to save the soil?